This is the third in a series of video-based lessons that will continue to introduce basic database lingo and represent a slight departure from the main objectives of this class to put database development in the context of overall information systems analysis and design, SDLC, you learned about in your Intro MIS class. We begin by talking about how database design and development cuts across all SDLC stages. We then briefly discuss the three database schemas as well as the concept of distributed databases. Next, we continue by emphasizing the main goals and phases of database development. We conclude by discussing the types of skills needed in different stages of DB development and the tools available to assist with both design and implementation. This material is covered in Chapter 2 of our textbook. Databases are not the only, but are often central pieces of any modern information system. They are definitely the most essential component because they store and provide access to all the data needed by the system. Other components, as you will know from your Intro MIS class, include people, users, procedures, hardware, as well as any application, software, web-based or not, interacting with DB. Let's continue with our simple sporting goods database. We would like to develop a web-based information system that will leverage the existing POS or point of sale system and allow us to connect to both our customers and vendors to increase sales, improve profitability, improve customer satisfaction, and manage better our vendors' relationships. After stating the problem and conducting the initial feasibility study, we press on with analysis of the current system and the requirements gathering for the future one. The crucial part of the system analysis phase is to determine business requirements with respect to information needs of the system. Again, this should all sound familiar from the Intro MIS class. Here we zero in on the main objective of this class, and that is the development of the data model for sporting goods database. This model, as you will learn over the course of the class, is represented by an ERD, or Entity Relationship Diagram, that supports the business requirements from system analysis phase. Notice that during systems design phase, other models will be developed, including process and user interaction models. All of the design models need to, ideally, come together seamlessly before moving into the implementation phase. In reality, there is a lot of back and forth between the SDLC phases as new requirements are discovered and or the old ambiguous one corrected. Design specs are coded, tested, revised, and then tested, coded, and tested again. For our class, Sporting Goods Database is implemented in a DBMS such as Microsoft Access or MySQL Server. After the successful transition from the old to the new system is completed, the maintenance phase makes all the necessary corrections and changes while database system is in production. I'm a big fan of Rapid Application Development, or RAD, where quick prototyping with simple tools like MS Access is used to clarify requirements before the production-grade MySQL or Oracle-based system is fully designed and implemented. Next, after placing databases within the context of the overall SDLC, we turn to describe the architecture and phases of database development. Modern databases are produced by defining the 3 or 4 schemas and then populating the database with data from a variety of sources like spreadsheets and text files. We will show how to do some of the data imports later in the class. The top tier is called an external schema, and it represents all the things the database user should be able to do once the database is in production. It is these business requirements that are driving the next tier, not shown on the top right graphics, also known as conceptual schema, which defines entities and relationships, and which we will study in detail. The middle tier, or logical schema, converts the conceptual one into tables, relationships, attributes, primary keys, and all the nuts and bolts that make for a solid database design. The bottom tier represents the physical schema, the specific DBMS implementation derived from the logical schema. Oftentimes, the lines between the conceptual and logical schema, as well as those between logical and physical, are blurred, but generally speaking, the higher up in the tiers, the higher level of abstraction. The lower you are, the more technical and nitty-gritty work can you expect. The distributed three-tiered DBMS architecture is another way of looking at the same database system once it's in production. The client tier represents the implementation of design components from the external schema, or, in other words, it contains the interfaces that allow the users to be able to do all the things they need to do when they connect to the system. The business logic or middle tier contains application programs that use the data from the database tier to process the data and turn it into valuable information for the users. We already discussed how data independence is one of the main advantages of database versus file-based approach. Because the database is a separate entity from DB applications that use its data, this allows DB design updates without affecting the applications. The database, or bottom tier, has all the design elements from the conceptual, logical, and physical schemas implemented and stands ready to be used by application programs and users in a myriad of different ways. Other physical implementation features like parallel DBMSs only add to the efficiency of transactional processing and the ability to deliver results of thousands of queries in the blink of an eye. Back down on Earth, we already encountered a simple two-tiered architecture with our sporting goods access database. You can think of customer entry form as the client-side user view of the customer data, without knowing anything about the actual server-side database implementation or any VBA code helping along the way. I know Access is just a simple desktop-based system where the DB file physically resides on the user desktop, or at best on a shared drive, but the principle of separating the application from the data is still the same. Other than the obvious one of creating a production-grade database management systems that satisfies all the user's current and future needs, database design and development will have many additional benefits. It will bring the entire organization on the same page in terms of common vocabulary. For our sporting goods example, this will improve the communication with customers, employees, and vendors. It will increase employee productivity because they will no longer deal with multiple spreadsheets, performing meaningless repetitive work of trying to synchronize communication between sales and fulfillment or billing departments. This will lead to fewer mishaps, so the customers will be much happier as well. The meaning of data will be defined precisely. There will be a single truth to what a customer is, what data elements are needed to describe one. The data will be complete, unambiguous, correct, timely, and reliable. The organization will enter a database Shangri-La. Most of the remaining slides go through all the stages of an SDLC with an emphasis on the database development. They echo the three schema development approach by starting with conceptual data modeling as part of systems analysis phase. A detailed user interviews with all the stakeholders of sporting goods company are conducted, and an exhaustive review of existing system is performed. As a result, a detailed list of business requirements is developed, but will likely have to be revised as more is learned in the future. The initial set of sporting goods information requirements is used to produce the initial ERD, or Entity Relationship Diagram. As was already stated, this will be one of the main subjects of this class. After refining and modifying our sporting goods ERD as new requirements come to light and or old ones are corrected, the logical database design is laid out by converting the final ERD into DBMS format. In our case of sporting goods company, the implementation actually means we have a rough prototype, since there won't be any actual production grade database system as a result of our work. This would be well beyond the scope of this class. Towards the end of the class, we will touch on some of the advanced database topics, including physical database design, but those will be cursory and brief in nature. As you undoubtedly noticed, the types of professional skills needed as you move through database development phases changes pretty radically. User interviews and conceptual modeling require more soft, qualitative, and people-oriented skills. As you get down into technicalities of logical database design and DBMS implementation, the harder quantitative and data-intensive skills tend to dominate. At the bottom of the slide are the engineers, which none of us are likely to ever become. Data modelers and analysts, or more generically, systems or business analysts, are the type of people with a good mix of people skills that do not shy from technical work and are able to competently talk to both the users on one end and the engineers on the other. As you know from your basic Intro MIS class, there are case tools out there that are useful for data modeling, documentation, and analysis. We will be using a simple tool called ER Assistant, which is fairly intuitive and easy to use, but does not have some of the advanced diagnostic features, ability to generate SQL code, or fancy wizards to aid with data modeling process. The third video of the class provided a high-level view of where database development fits into the overall SDLC. The key message is that it cuts across all the stages and is central to the development of any modern information system. We also examined modern DBMS architectures and then went through each of the SDLC stages with emphasis on database development. We discovered that as we move from the analysis through design and into implementation, the database development skills change from softer, people-oriented to harder and more technical. We concluded by mentioning the use of case tools in the context of data modeling and introduced ER Assistant, our friendly data modeling tool.